Newton's law of cooling. We all know that hot water or milk, when left on a table, begins to cool gradually until it attains the temperature of the surroundings. Let us perform the following activity. Take some water, say 300 ml, in a calorimeter with stirrer and cover it with 2-hole lid. Fix the thermometer through a hole in the lid and make sure that the bulb of the thermometer is immersed in the water. Note the reading of the thermometer. This reading T1 is the temperature of the surroundings. Heat the water kept in the calorimeter till it attains a temperature, say 40 degrees Celsius above room temperature. Then stop heating the water by removing the heat source. Start the stopwatch and note the reading of the thermometer after fixed interval of time, say after every 1 minute of stirring gently with the stirrer. Continue to note the temperature T2 of water till it attains a temperature about 5 degrees Celsius above that of the surroundings. Then plot a graph by taking each value of temperature delta T equals to T2 minus T1 along y-axis and the corresponding value of T along x minus axis. You can also notice that initially the rate of cooling is higher and decreases as the temperature of the body falls. The rate of loss of heat depends on the difference in temperature between the body and its surroundings. According to Newton's law of cooling, the rate of loss of heat minus dq by dt of the body is directly proportional to the difference of temperature delta T equals to T2 minus T1. And even the loss of heat by radiation depends upon the nature of the surface of the body and the area of the exposed surface. Minus dq by dt equals to kT2 minus T1, where k depends on the area and nature of the surface of the body. Suppose a body of mass m and specific heat capacity S at temperature T2 and T1 be the temperature of the surroundings. If the temperature falls by a small amount dT2 in the time dt, then the amount of heat lost is dq equals to ms dt2. Therefore, rate of loss of heat is given by dq by dt equals to ms dt2 minus dt. Equating above equations, we get minus ms dt2 minus dt equals to kt2 minus t1. dt2 upon t2 minus t1 equals to minus k by ms dt equals to minus k dt, where k equals to k by ms. On integrating, log of t2 minus t1 equals to minus kt plus c, or t2 equals to t1 plus c dash e power minus kt, where c dash equals to e power c. This equation enables you to calculate the time of cooling of a body through a particular range of temperature. Newton's law of cooling can be verified with the help of the experimental set minus up. The set minus up consists of a double-walled vessel V containing water in between the two walls. A copper calorimeter C containing hot water is placed inside the double-walled vessel. Two thermometers through the corks are used to note the temperatures T2 of water in calorimeter and T1 of hot water in between the double walls respectively. Temperature of hot water in the calorimeter is noted after equal intervals of time. A graph is plotted between log of T2 minus T1 and time t. The nature of the graph is observed to be a straight line having a negative slope.